Hi, my name is Doug Vogt from the Diehold Foundation, and this is video series 1, 1H. And I'm appending it to the end where I talk about black holes and quasars and galaxies. The reason I wanted to include it with these major reasons, this video is going to finally kill the idea once and for all that there are no black holes in the center of galaxies or quasars. And I'm going to partially do it with the writings of Stephen Hawking, the poster child for black holes. And you're going to learn a lot, and you're going to see how he evolved and where they made the critical mistake in logic. Anyway, we're going to cover the crises in physics. There's about 5 of them. I covered it also in the previous video. Why the physicists accept that black holes were in the center of quasars and galaxies. How did the mathematical fantasy of black holes begin? Why did Stephen Hawking change from the idea of black holes to a holographic universe? And yes, I'm not kidding, he did. And you'll see the whole progression. I'll be teaching from God's Judgement book, chapter 3. This is the latest version of the Theory of Multidimensional Reality. I'll probably have to do a second edition and add more stuff. I'm also going to cover the gravity and time experiments I did here, which helped prove my point. And that's in video series 3. And then finally, creation of the Hebrew alphabet. You'll say, why am I putting that there? You'll see it, you'll understand why in the very, very end, but I'll cover it very shortly. Okay, we'll start in. These are the main 5 points that at the time of Stephen Hawking's and in the early 60s and late 50s, this is the crisis they had in nuclear physics and astrophysics. The first was, which I covered also in the previous video, but I'm going to just lightly cover it here. Discovery of quasars in the late 50s and 60s. These things were producing 10 to the 58 ergs. In fact, Stephen Hawking refers to one 10 to the 60 ergs. That means it was an output for this quasar of 500 million of our suns being burned up per second. That's assuming a star is made up of only of hydrogen, and it's converting hydrogen to helium. The output is also about 4 trillion times that of the sun, or 100 times that of the total light output of a galaxy like ours, the Milky Way, a pretty big galaxy. Estimated over 200,000 quasars are known. It occupies an area the size of 1 astronomical unit, which is the distance from our sun to the Earth, 93 million miles. At first they thought it was like 1 light year, then they got down to a half a light year. Then they realized these things are really small. I mean, 93 million miles across, and this thing's pouring out hundreds of millions to billions of stars. At some point you have to say, wait a minute, something is coming from nothing. But the problem was they couldn't explain the energy output of these things. What it really means is that a star or a quasar would have used up all the lighter elements, probably even including carbon. Everything would have been used up, which means we wouldn't be here right now, which obviously we are, therefore the philosophy is wrong. Number 2, neutrinos. The idea of neutrinos was instituted by Wolfgang Pauli in the 1930s to try to explain beta decay. The sun theoretically produces 65 billion neutrinos per second per every square centimeter on the Earth. So depending on how big you are, now you know how much the scientist thinks neutrinos are passing through you. But they've done the experiments that 100,000 gallons of carbon tetrachloride in some deep mine, I think in Illinois or someplace in the Midwest. And they were hoping that a chlorine atom would wind up getting hit by a neutrino and become chlorine-37, a radioactive chlorine that they could detect with a Geiger counter. How many did they detect? None. In the previous video, I show over a dozen experiments they've done trying to detect these things. And they come up with wonderful excuses, but they didn't find any. The last outrageous one was the detectors in the South Pole. They drill a hole in the ice down, all the way down to the bottom. And these things that look like flying saucers, they attached, and hopefully they're going to detect something. They never did. But they spent a lot of our money. Oh, they're very good at that. Oh, yeah. Next is a real problem they have is mass. Mass is connected to gravity. Now, can't have gravity unless you have some atoms or mass. The problem is in subatomic particles, there's about one of the previous videos in Series 1, I counted 155, 156 subatomic particles, both the positive and negative version of them, and there's about 53 or 54 theoretical particles. Put particles in quotes. And at some point, somebody's going to say something's wrong with the foundation philosophy, but no, they're going to beat this horse to death. And actually, I'm the one who's going to bury it finally. So how do you wind up getting to black holes, which is an infinite gravity, if you don't know what gravity is, if you don't know what mass is? You know, when you stand on a scale, they don't know why you weigh anything. If all the subatomic particles that make up the atoms have no mass, they're all measured by electron volts, then what are you weighing? I mean, what are they weighing? Now, explained in Series 1 using the theory of multidimensional reality. That you have information that makes you up, and they have information that makes up the planet, which is a lot bigger. What we're really weighing is the amount of the information that makes up the planet influences the information that makes up your body, both the soul part and the physical matter part, the atoms. That's really what we're weighing. But they haven't quite gotten to that level yet. So that's the main philosophical problem here. They don't know what gravity is because the mass has no weight. So the atoms have no weight. So what is it? That's why they came up with the idea with the Higgs boson, which I'll cover in a few minutes in 2 more slides. They're all theoretical mathematical creations. It's like loose change. 4, if quasars were produced by a black hole in the center, then what formed the black hole before it became a quasar? So they don't want to explain that. You know, they say, okay, you got a black hole, but they say, okay, where did the black hole come from? Now, the explanation we have of a black hole, you got a real big star that uses up all its nuclear fuel, and it compresses down and gets to a point where it goes to a singularity and it becomes a black hole. But that means you have to have a star beforehand. What formed the star? It has to go through a whole cycle, which I covered in the previous video. And they don't talk about that at all. It's very reminiscent of when Noah tried to explain the deep sea canyons. They explained the canyon on the continental shelf, but when it tips down, where it goes down to 10, 11,000 feet below sea level, they stop there. Don't look there. It's like don't look at the guy behind the curtain. When they can't explain it, it drops off like it doesn't exist. By the way, there was someplace I read in one of the journals from a famous big name physicist. He asked, it was in England, he asked his professor, what is mass? And the professor said, we don't know, and never asked that question again. A little disingenuous. You begin to think that, gee, I've spent $30, $50, or $100,000 for my education, and he's telling me what he's teaching me isn't worth the paper it's printed on. Final, theoretical imbalance between particles and antiparticles. If they were equal, the universe should not exist. Now, in the previous video, 1G, I showed the article. At that point, you wind up figuring out that your philosophy of science is wrong. They have built a philosophy, this mathematical model of nuclear physics and astrophysics and stuff like that. They didn't build it on shifting sand. Actually, when sand gets wet, you can drive a car on it. They built it on talcum powder. But they don't want to give it up because, remember, The schools are in the business of selling you a degree, and they have to make you think that what they're teaching was worth what you're paying for it. Pauli came up with the idea of the neutrino, but this is how they prove it in November 1970 in a bubble chamber. Here's an atom. Something hits it, and you got 3 tracks. Now, they have no idea what these 3 tracks are. They label them as a mathematical label, a mu meson and a pi meson, proton path here. Now, I went through using the theory of multidimensional reality. An atom is made up of thousands of frequencies. Some are stronger than others. Just look at the light spectrum of any element. Excuse me, I'm getting over the flu. That's why it took me some time to do this video. And so some of the stronger frequencies go out like this. You see them. The weaker ones you won't see unless you really bang the crap out of it, like in the CERN accelerator. Then you got thousands of tracks. Higgs boson. Boson was a field. Here, they see an atom goes like this, and all of a sudden something hits it here. So they came up with this idea of this field, of a Higgs particle, and it goes on as a Higgs boson. And the Higgs boson, this field, is supposed to give the subatomic particles mass. That's the problem. Einstein's special theory of relativity, or general theory of relativity, was 1915. Within a month, Karl Schwarzschild, another Jewish physicist, came up with the solutions, the mathematical solutions for the general theory of relativity. And he was very famous. He came up with the Schwarzschild coordinates, Schwarzschild metric, Schwarzschild's radius, Schwarzschild's black holes, and wormholes. He's the guy originating and came up with the idea you can have a black hole and maybe a wormhole. Then along came David Finkelstein in 1958, determined that whatever falls past the Schwarzschild radius, that's this, from here to there, into a black hole cannot escape. The membrane is one-directional. And here's singularity. Here's the event horizon. I've seen numbers quoted by Stephen Hawking that singularity is 10 to the minus 33 centimeters. That's smaller than what they think the center of an atom is, which kind of is ridiculous to me, but this is an artist's concept of a black hole. I have looked at least 1,000 galaxies. I have yet to ever see a black thing in the middle of it, always glowing quite bright. This is all the imagination of an artist. Max Planck, also extremely famous German scientist. There is no matter as such. All matter originates and exists only by virtue of a force. We must assume behind this force the existence of a conscious and intelligent mind. The mind is the matrix of all matter. I call it the operating system. I regard consciousness as fundamental. I regard matter as derivative from consciousness. Here is Stephen Hawking. And I didn't show the picture with him in the wheelchair. I don't think he saw himself in the wheelchair as a cripple there. I think he probably thought himself when he was healthy or semi-healthy, married, and had a happy life. I have mixed feelings about him. He was a very gifted mathematician, but a lousy philosopher. He should have come to his conclusion a lot sooner than when he did. He started doing his work regarding black holes in 1971. This is where I had some fun. There is published, it's online, I think it's in Oxford, They have all the publications and books he ever did. I have it here. And there's over 233, of which 16 of them are books. The ones that are in yellow, I couldn't, at the time, couldn't download them from Nature or wherever they were because they didn't let me. I didn't feel like spending $39.99 for the issue. But I was able to download 49 of the articles that were free, and I read them. And I don't know how many people have read his stuff, a little dry reading, a lot of math, but I understood what he was getting at and was saying. So I'm going to try to show you. I made columns. This is conditional statements. If, could be, may, things like that, where he sets up a condition, and then he tries to explain, okay, with this condition, this could be true. But when you write a paper, if 2 or 3 of your assumptions are wrong, your whole premise could be totally wrong. I made a column also for hologram, which he doesn't call, he calls it holography. Black body radiation is really originally what they thought of as a black hole. They have black hole, and then how many times he mentions quasar or a galaxy. The X is where they do mention black holes, but I don't know how many, so well, if I put yes in, it means there were so many that it was pointless. It's just a lot. So you'll see, this is his PhD thesis, which I have and I read, about 160 some odd pages. 72 conditional statements, ifs in there. Interesting. And mentions quasars only once. Now, remember, they were first called, they were radio noise, very high radio noise, until later they resolved an image with the radio noise, and then they called a quasi-stellar object, so quasar. Anyway, it goes on. First, singularity, which is a black hole. He focuses on these for most of his writings. Here he starts black holes. It's about 71 he really is into black holes. And you'll see how many papers he's got and which ones I can access. But look how many conditional statements. Like in this one, why the universe isotopic? 51 conditional statements. That's a lot. Singularities of gravitational collapse, 47 of them. Black body radiation mentions 2. He's trying to explain quasars, the output of quasars. And one of them was important. I'll show you here. Particle creation by black holes. This is important, and I actually have it. Read it, 75. And again, 19 conditional statements. Black body radiation mentions black holes, not quasars. And he's trying to explain why they see out of a quasar millions upon millions of stars pouring out of it. So if he says, if they all think that a black hole is in the center of a quasar, how does a quasar produce matter? So he wrote an article, this one, to try to explain how this could possibly be. So that's where he goes. Let me go on further. These I couldn't get in, but I've read all the abstracts of them. So black hole, quasar ones, black body radiation, again, that's almost synonymous with a black hole. Then around here, all of a sudden we were able to get my hands on them. Either the journals did not publish the articles because it was either they didn't want to bother or it was too theoretical. Again, look how many if statements are going on here. Now, if you got 2 or 3 or 4 of them, the whole premise may be wrong and probably is wrong. Now, I was very generous with the if statements. When it was in a mathematical formula, sometimes you have to have an if statement in there. So I didn't count those. I only counted those that were really within the subject, that it was, if this condition exists, then this is it. More of the same now. We're going to start getting into where he starts changing. So conditional statements, a lot of them. Black holes, Yes. Doesn't mention holography or holographic at all yet. You'll see that changes real soon. Quasars here. Volume weight in no boundary proposal. This is where it changes. And this is the article, and the references change this mind. And I have that one. Except I didn't bring it upstairs here. There's a bunch of articles in here that mention holograms, holography as an analogy. 14 conditional statements, but this is an important article for him. From then on, it changes. Vector fields and holographic cosmology. You could see within the 3 years. Now, Judgement was published in 2007. Reality Revealed, it's been around 1977, 78. So this idea that the universe is a product of information has been floating around out there. But he never goes into saying it's information. It's just called holography. Now, some of the other early articles, he talks about a black hole doesn't destroy information. Anyway, quantum probabilities and inflation from holography, a holographic universe. Why is it expanding? Singularities, okay, information paradox of black holes. Then we start getting more of the hologram stuff. But notice the conditional statements drop down dramatically. This one is his last paper. Got it here, read it a couple of times. He mentions holograms 28 times. Black holes disappear. Disappear. No conditional statements. Just like in this one, holograms, no conditional statements. None. So I'm going to tell you what happened. I don't know why he waited and had this thing published only after his death. He should have done it before. A little bit of a cowardice on this one. Maybe he didn't want to get criticized. But in this article, and partially in this, he's basically disavowing all the articles and ideas he had about black holes written from his PhD thesis to there. Actually, this one I can include in there also. So from 2013 back, he's disavowing. He's basically telling you there is no black hole. When you actually read the articles, I have one that was a paper in there, and let me see. This is the article, his final one, what it looks like and stuff like that. And I covered it in the previous video, so I'm not going to dwell on it. But you have to understand, to say the universe is a hologram, you have to be saying that we are a created reality. There's two ways to create a hologram. One is you have the object, and you have two reference beams, lasers, and it reflects through mirrors to another point, a coordinate, where the two lasers come together and it reflects and shows the image. This isn't the case here. We don't have two universes. The other way is a computer generates the reference beams and creates the hologram. So you can't wind up separating information from a hologram and concluding that the universe is the product of information. He's flat out saying it, but only indirectly. He didn't want to go that far. And I think the reason is he was a lifelong atheist, and he knows if we're in a synchronous system, then the operating system has got to be what we call God, period. And he doesn't want to deal with it. So he stops and doesn't go as far as I have. Remember, I figured all this stuff out 50 years ago. Okay. Stephen Hawking, there are no black holes. Article from Nature, here it is. And the guy who's reported this, I have his name later. Anyway, notion of an event horizon from which nothing can escape is incompatible with quantum theory physics claims. If Hawkins is correct, there could even be no singularity at the core of the black hole. The absence of event horizons means that there are no black holes in the sense of regimes from which light can't escape to infinity. There's the reference. Hawking told Nature, that's this article, quantum theory, however, enables energy and information to escape from a black hole. A full explanation of the process the physicist admits would require a theory that successfully merges gravity with other fundamental forces of nature. But that is a goal that has eluded physicists for nearly a century. Actually, it's 105 years. The correct treatment, Hawkins says, remains a mystery. He's admitting he doesn't know. The theory of multidimensional reality, and the reason why I wrote the books and I did these videos, is this theory explains it. It explains what gravity is, what light is, what magnetism, what everything is. And on top of it, I found the clock cycle that proves this thing is we're in a created reality. Let me explain. The reason why these very smart men got screwed up is because the foundation philosophy we were all taught was a matter-oriented theory of existence, and it's not correct. In fact, you don't even know why you have it. But in Series 12, you're going to find out, and you won't like it one bit. They claim they found, they photographed a black hole here. That's a composite picture done by a computer. Excuse me. This is Dr. Pierre Robinelli. He has a channel on YouTube called Sky Scholar. You should watch it. The ones you should watch that deal with this and debunks this is April 10th, the October 19th, January 6th, and February 22nd. He goes into it, and I'm going to show you very briefly what he said. That this is a composite made-up picture, and they don't have enough data to have ever created that picture. It's almost like an artist's rendition. They used these points in telescopes. There, ALMA, up there, these points. And these are the signals they got. Now, what the professor is saying, if you took a line across here, you'd only have 1, 2, 3, 4 signal observations. He's an expert on signal and MRI. You can't make an image on only 4 hits, or some of them only 2 hits, 1 hit. You need 500 to 1,000 to make a picture. So this is a real stretch to try to get anything out of it. And what he says in the videos is the only reason no one's called them on is because it's astrophysics and nobody wants to deal with it or can understand it, and they'll just accept it. But you shouldn't. You always ask the questions whether the guy's right or not, or how they got the information. Remember, the devil's in the details. This is the details, and this guy's right. That was a made-up picture. This is the late theoretical physicist Joseph Polaczynski. He was only 64 years old. Too bad. He's the one who wrote some of the comments that you saw earlier. Said in the Nature or News article, in Einstein's gravity, the black hole horizon is not so different from any other part of space. We never see space-time fluctuate in our own neighborhood. It's just too rare or on large scales. Guess what? He's wrong. I don't expect him to know this stuff because he didn't do the experiments. That's what I did in 1996 and 92. I'll tell you how I did it. I had a friend of mine, Hal Phillips, wherever he may be. He built me 25 megahertz crystal, 9-volt battery, coax connection. I had two coaxes, one 200 feet, the other 113 feet long, shielded coax. And I had, some of you guys are going to laugh, my Heath kit frequency counter. And it goes into 35 megahertz, but it also does hertz, regular hertz, down to single hertz. I built this thing from a kit. So I tested it in Bellevue, Washington, and for the first few minutes, like about 15 minutes or so, the battery and the crystal have to hit an ambient temperature. And then from then on, it was more or less flat and level. It was pretty consistent. I was pretty happy. I already tested this thing several times. This one was over 7 hours. So I knew I had a stable environment. So, general theory of relativity. As you approach the speed of light, time slows down and size gets smaller. That's the general theory of relativity. Nobody's arguing with it. Now, there's 3 or 4 gravitational mystery spots in the United States. They've been built like they put a misshapen cabin on top of it, on top of these vortexes, and they have you come in and measure, and of course the building's crooked, so it's an optical illusion in some cases, but sometimes it isn't. But there's 2 things that all the optical illusions may have there become irrelevant and doesn't matter. And that is time. And if you have 2 measuring sticks exactly the same size, or 3, and you measure them over time, that they can't change. That's not an optical illusion. So here's mystery spot in Santa Cruz, California. Here's Stanford accelerator in a great physics department, about 35 or 40 miles away. And here's Berkeley, and home of Luis Alvarez and his son, and a very big physics department. I've known 2 of the owners of this mystery spot, Santa Cruz mystery spot. And I asked them, they told me, no scientist from there or there, anybody, ever came there to do any experiments. The reason is these guys don't do anything unless you pay them. The grant money, follow the money trail. They never bought, they didn't have the curiosity. He said, one of them said there must be a large meteor down there. If a PhD said that, I'd take his degree away and say, you're too stupid to teach. Really too dumb. So, with my 25 megahertz crystal, which stabilized at 24.99 something or other, these are just the last 4 digits on the thing, down to single hertz. And this is the center of where they think the vortex is, and this is the outside was someplace way out here. And you'll see this thing change, 18 hertz over time duration, 3:31 p.m., duration of the experiment, 7 minutes. As you go out, the frequency dropped down. Here, did a little opposite. 19 hertz, it went up, then down, then up, and down. By the way, you're going to see when I do size, this thing's changing dynamically. I'll go through the thing fast. Total difference, 60 hertz. Crystal left at 40-foot mark, starting at 5:14 p.m. Duration of the experiment, 5 hours and 25 minutes. Here's the time. Look, time went up, and then it dropped down, and then went up. Gee, I guess the good professor's wrong. Time does change. And you'll see size changes also. Here, crystal left 40-foot mark, duration of experiment 69 minutes. Change 31 hertz. This is all in the book, by the way, with greater explanation than I can do here. Oregon vortex. The other one was Santa Cruz. This is Oregon vortex. Here's the center of the vortex, where they think it is. And started at 1 p.m., experiment 16 minutes. Basically, these are the points I took all the way out to the edge of where they think the edge of the vortex is. The drop of 36 hertz. Here, 28 hertz difference, 6 minutes. 0 the center, 10 foot, 20, 30, 40, 50 feet away. And here's the frequencies. 110 hertz, this is, again, Oregon vortex. 15 hertz, 50, 60, 70, even further out. But you know, it was pretty far, like 200 feet in diameter what this whole thing was. This one is 47 minutes, and it went up and then down, all the way out to 200 feet from the center. Now, 110 hertz difference, if you use Lorentz transformations, which Einstein uses in the time formula, part of the formula, then 110 over the frequency of the clock, it would be equivalent of traveling at 552.6 miles per second. I didn't know I was going that fast and going through this vortex, but hell, how could Einstein possibly be wrong? Start time, 2:04, 33 minutes, 41 hertz. From the center, out. 22 minutes, 50 hertz difference, out and down. 22 minutes, again, all over the place. There's the center, so we went out, in, and then out. Then I did this. I did it for about 1 minute, and I measured the clock's 30 hertz range from there to there. But these like 10 hertz. 10 hertz, every minute was going up and down. It's really wild. So this thing's really changing. Now you'll see when the size things in the Oregon vortex, it was changing dynamically. Here's Confusion Hill, and this didn't measure as much as the other ones, but here it is. This is where they think the center is, and we went out, it went up. Here it went down. But you can see it goes both ways. You can't say it's one. It goes both ways. What's going on in what I theorize in the buried down where these vortexes are is some device that is altering the rate at which information comes into this dimension to whatever makes it up. Now, photographing the stands, this is what we did. Camera stand, camera, leveled it out. That's how we did it. So, this was done 1992. This is what I have on the photographs. I measured from the base up to the top, which is 7.5 feet. That mark is 7.5 feet. This is feet. I had 3 poles. This is where they think the center of the vortex is. It's actually in the back corner of this shack. And no, this is further out, this is closer in, theoretically. The change from there to there, now the pictures, all the pictures you're going to see was at 300 dpi, and I measured it in Photoshop, so it's measuring pixels. This is how many pixels it is. So the right, middle, and left. So 3.3% change, difference between there and there. Now remember, we're just setting up the experiment. You're going to see something really funny. Then a little kid shows in the picture. I took the picture anyway. And the little time that the kid shows in the picture, it changed to 1.9%. Remember the frequencies, it's changing dynamically. So this is an old friend of mine who I don't see anymore. His name is Mo. There I am, a lot younger. Well, what I looked like in 1992. And I ignored the height. I'm not measuring us. I'm measuring from the base of this thing to up there. So don't worry about the pictures. It's irrelevant. But look, this is within a few minutes of the other. We set up the camera, I turn it, I delay the picture, and I stand there. And look, 4.3%. 7%, which all we did was switch places, and I did the camera. It's a few minutes apart. 7% change. 5.6% change. 7.1% of the change. This is at Santa Cruz Mystery Spot. Setting up the experiment, measuring just the poles. 4.8%. A few minutes later, 3.7%. 3.2%. Within minutes. Again, 3.2%, almost the same. This is a table of what I've shown you. And basically, these things are changing dynamically. Now, this is one I took earlier, another one, 5.1%. This is Santa Cruz. They took these pictures. I don't know how they took them or when. They record a 14.3% change and a 24% change. That's absolutely amazing. It really is just amazing how much it is. This is what I think is going on in these vortexes. If you graph it, something is buried way down here. It's modulating information that makes it up or its environment, and it's dynamically changing. I mentioned in the book and video series 3, which covers the experiment, that at the Oregon vortex, first there was nobody in the vortex. So I had crystal there, and I was outside of it. And then about 6 or 7 young people walked into the vortex, and the thing went nuts. I mean, it just went up and down, crazy. So it is affected by humans coming into the environment. This is polar coordinate graph, but a logarithmic graph. I think this is how you have to look at it. So if the cabin's like here, and their poles were like this, it's not exactly true. I don't think they really have it like this, you know, that it's dead on. I think it's probably more like at an angle like that. The only way you really know for sure is if you had a string of these things, multiple, every 10 feet from where you think the center is out, and you had a computer or multiple computers recording it in real time, you'd then get a better pattern of how these things are modulating, but there's something really down in there. We're almost done. This is the last of it. Okay. So this book is not a religious book. Library of Congress indexed it quantum computing. It's the first physical evidence we have that an extremely highly advanced previous civilization existed on this planet. And the reason why I put volumes 1, 2, and 3 up, volume 1 tells you why Abraham bought that cave. He was lured there, or a curious guy, and figured it out, and bought that cave. This is the model for the Hebrew alphabet, but it's the model for how matter comes into this dimension. Every element, this would be the carrier wave that makes up, let's say, one element, let's say gold. And when it crosses this imaginary x-axis, it blurps out and becomes what we see as gold. I realize this is Planck's constant. This is Planck's time. So you can have an atom that's positive and also negative. That's why they have positive and negative particles. Depends on when you hit the damn atom. So this would be a graph for the third dimension, inanimate objects. Fourth dimension, you'd have another one or more of these carrier waves that make up us. We're fourth dimensional beings. So fifth, sixth, seventh, and eighth, keep adding these carrier waves. Each one is exponentially greater than the previous. So what's happening with a quasar? What is it? The Diehold, which I believe is the name I give this computer that creates this created reality we're in. It can't allow too much information. Information would be gravity in this case. It can't allow a black hole, an infinite gravity, to a point in time and space in its creation. It can't do it. It would make the system unstable, and it's not going to do that. That's one philosophical reason you can't have a black hole in this reality. Just like on the flip side, you can't have a tear in the universe. A tear would be too little or no information. You want to know what that is? It's real simple. Let's say U-235, you bind the crap out of it, you compress it, and then it explodes, and it converts from U-235 to two lighter elements that when it adds up, the two lighter elements, it's almost the same as the U-235. And that little bit of difference is what they say, that's what makes that big explosion. With the theory of multidimensional reality, what you're really looking at is this Diehold pouring whatever stable information is necessary into that point in time and space to stabilize it until all that U-235 is split up and used up and becomes these two other more stable elements. So it won't allow a black hole and it won't allow a tear in the universe. Otherwise, you wind up seeing more energy than you could figure out ever was in the system. That's why they can't figure out why it's producing 10 to the 58 or 60 ergs. It's not within this system, the creation, that's doing this. It's the thing that creates us can pour whatever information it wants in. Light is information. You see this kind of information? It's pouring it in. It has no limitation. Well, my parting note. The theory of multidimensional reality is the unified field theory. That's what it is. If you think I'm wrong, try to prove me wrong. No one has in 50 years. I've had too many guys steal my ideas, both scientists and movie producers. Intuitively, I think we do know it is. It explains everything, including consciousness and why we die and why people come back and have visions and stuff like that. It's, I mean, you have to give up the idea that your body is it. Of course, at the same time, you're going to give up some of your ego, but that's just the way it is. But my hope is that enough people will understand that this clock cycle is going to happen, and that's where the rubber hits the road, where this theory becomes real to everybody. And you only have 26 years left before this event most likely will happen, and that's explained in the other videos. Anyway, I hope you enjoyed this. I hope you got something out of it. And now you know there are no such thing as black holes anywhere.